Thank you for the wonderful introduction. Already the words are not happening. Brilliant. Thanks for coming to the talk. The room is pretty full, so I'm glad that you will hopefully enjoy this talk. So we're going to talk about PHP's type system. So a bit about me. So you can find me on Mastodon, on Twitter, on GitHub, or on my own website, where I will upload these slides. Like said, I work for the part-time on the PHP engine, founded by the PHP Foundation. I study pure mathematics, so there's going to be a bit of maths in this talk, so I hope you won't be traumatized and bringing back to your university years. Like said, I do maintain the documentation and stuff like that, and I care about type systems, and I care way too much about PHP semantics. So we'll be seeing all of that. So this is the order of business. PHP's type system first, then what subtyping means and Liskov substitution principle, and then all the wonderful ways our daily programming language type juggles and type coerces stuff in wonderful ways. So what is an actual type system? So a type system is a logical system comprising of terms and a set of rules which assign the property a type to different things. And the type system dictates what the operations can be performed on each term. So like in a programming language, typically, a term will be a variable or a function or arguments or properties to a class, and a type then will tell what you can do to it, or how you can extend it with various algorithms that you can implement in functions or just in a for loop or different things like that. So in PHP, we've got a couple of different things. So we have primitive types, which means that every single value in PHP will resolve to one of these types. Users, so in userland, you can all define your own types. There are a couple of literal types, and we'll see what that means. The callable type, which is its own special mess, because that's what it is. Composite types, and then type aliases. Okay, the clicker half works. So PHP has a thing which is called the universal type, which is mixed, i.e. every single type is a subtype of mixed. So it covers the whole type sphere. Like if you think of the type system as a blob, every type resides within mixed. Resource is a type that exists within the engine that you cannot declare your functions to use. The main reason for that is that resource is this black box thing that the engine is just like a bunch of memory, it's a blob of memory. And the reason why we don't allow you to add a type declaration to it is so that we can convert these resources to objects, because they are way more useful, because objects, you can actually type objects. So since PHP 8.2, you actually can use the object type hint, or type declaration, and use it. Array, wonderful god-like data structure of PHP, which is an array map, like a hash map, a mapped order, a list, a stack. Whatever you want it to be, it can be it. Then a couple of scalar types, so Boolean, integers, floats, but also, more importantly, strings. PHP considers strings to be a scalar type, which, if you do comp-sci, can be a bit weird, but we'll ignore that. Null is called a unit type, because you might think it's just a value, but it's also a type which has only a single valid value, which has its use cases to mainly indicate this is the return value is useless, or you don't need to care about it. Never is what we call the empty type, and which is available since 8.1, which basically means the function never returns, so it doesn't return a value. So where this arises is if you have an infinite loop, if you throw an exception, or if you exit the program. These are the three cases in PHP where you can technically type a function to return never. And then we have this weird child, which is called void, which is a bit of a lie, because every single function in PHP will return a value. So if you call a function which types itself as void, you will get null as an output. Void is kind of the lie that, I don't know, people decided it was a good idea. Was it? Who knows? We'll see. The more interesting thing, I think, for most people are user-defined types. We also call them class types because they're all based on classes. So these are actually interfaces, classes, and enumerations as of PHP 8.1. And these allow you to define your own domain logic or values that only, like value objects. I'm pretty sure everybody uses value objects here. Value objects are a way of adding a type to an object, so then you pass this along and you guarantee that, okay, this is what I'm working with and I know what I can do with it. And like, what are the properties, what are the different fields it has, and what I can do with it. Now, there are a couple of relative class types, which is self, parent, and static. You can use them in type declarations. Like, you can say that you want an argument of a parameter to be of a parent class. If you ever do this, why? But you can, because that is part of the type system, so it allows you to do it. Yes, so literal types are specific values within a type. PHP only supports 2 of them: false since PHP 8.0 with an asterisk, and true since PHP 8.2. The asterisk is because you can only use it in union types prior to PHP 8.2. So you needed to do something else false, and you couldn't use it standalone. But yeah, and it's impossible to define one in userland. If you want to do this, just use an enumeration, because it effectively does the same thing. So yeah, the callable type represents a function in PHP. And a function in PHP are 3 things, basically. It can be just a literal string, which is the name of the function. It can be a pair, like an array, like an instance of an object, or a method that you want to call on this object. An object which implements the invoke, a magic method which basically turns out, okay, like if you call it, it will call this method with all of the arguments you pass it, and then you can do whatever you want with it. Or a closure, and you can obtain closures in a very nice and elegant syntax with the 3 dots, like as of PHP 8.1. So the 3 dots doesn't mean that like I'm fill out the blanks. It actually means *n, like bracket, 3 dots, bracket, and that will give you the closure which represents the string length function. One caveat: you can't define a property to be callable due to some scoping issues. If you want to store a function in a class property, use the closure type, and then just obtain a closure via the new syntax. Okay, composite types. So composite types allow you to take building blocks, so all of the single types that you might be defined or defined by you, like already by PHP, and compose them to make larger types. So we got 3 sorts. So we've got intersection types, which are available since 8.1, which means that, like, okay, I want a type to be of type A and of type B. Simple union types, which exist since PHP 8.0, which means I want something of type T or type U. Technically, you could do union types with null since PHP 7.1 by using the question mark, which basically is equivalent to T pipe null. And since PHP 8.2, we have these things which are called DNF types, which are like types in disjunctive normal form, which basically types which are a list of ors that comprises ands. So we're doing like, okay, I want something to be X and Y, or I want something to be V and W. The reason we do this is because it just makes it easier to implement in the engine. That's the main reason. We could support arbitrary weird stuff, but then you get into the thing where, like, okay, you get into recursive nesting, and that gets performance hit, and then you get into the thing of, like, does this ever terminate? Which is not a good, fun problem to have. So that's the main reason as to why we force it upon you, the user, to write the types in disjunctive normal form. So why do we actually care about composite types? So just for the lack of space, I'm using C and T. Use the interface for countable and traversable. So the intersection type is the middle. If you take like the square box to be all of the types that exist within the type system, you will have a bunch which only implement countable. You will have a bunch which only implement traversable, and then you will have some which implement both, which are represented in the middle by the purple area. And the reason we care, I think, why intersection types are, in my opinion, the more powerful tool is because it tells you, oh, I can use the API defined by the countable interface and by the traversable interface. Whereas a union means that you can only take the common API between all of the types in your union. Now, if you're doing something which is a union of countable and traversable, you actually can't do anything with it because they don't have any common APIs. Like, I can't call count on an object which is just traversable, and I can't traverse it's technically a lie, we're not going to mention this. You can technically for each over any object, and it will use it as a key value pair. I should have thought about a better example. Streams are a great example. You could also have like a stream and say, oh, okay, the stream is only readable, or add a new interface, it's writable, or it's seekable, or you can like do other stuff. And the more intersections you add to your types means the more APIs and the more abstractions you can use within this type. And it also allows you to segregate interfaces into smaller entities that you can like implement more individually instead of having like one humongous interface, which is like, oh, this is allows me to do X, Y, and Z, when you could just have them split out into different interfaces and just use intersection types to tell you, okay, I want this to happen. Still this clicker. Maybe should have. Yeah, so intersection types gives us access to all of the APIs, whereas union types only gives us access to the common APIs between the types. So type aliases. So as of PHP 8.2, iterable is now a compile time alias. This has to deal with implementation details to make DNF types work. But previously it was just a pseudo type, and it's just defined to be traversable or array, because array being a primitive type, it can't implement interfaces. So yeah, that's kind of the point. As of now, you can't implement any type aliases in userland. Okay, so we're going to see a bit of C code, tiny bit, and this is how PHP basically, within the engine, every value is represented as a zval. And a zval has two fields. It's basically a zen value, which is a union of types like internally, and what type it actually is. So you will basically check if you declare a value to be of like an integer. When you pass any value to this function, it will check that the type info corresponds to the is long thing, which corresponds to an integer, because long is a C word. So yeah. Still clicker. Okay, so types in PHP are represented by a Zen type structure, which is a really simple structure which takes a pointer to some memory and a mask. The type mask is there to take a bit mask of all of the primitive types, and that's how it checks. Where if you pass it a pointer, like it can be either one of two things. It's either a string, which corresponds like of a class name, or it is a list of types, which is then recursive, which is another part of Zen types. And this allows you to check for like classes and interfaces, and is how union types and intersection types are implemented, because you now have a class list instead of just a single type. Okay, subtyping and what Liskov substitution principle means. So what is subtyping? Subtyping is a form of type polymorphism in which a subtype of a data type is related to another one by some notion of substitutability. Reading is hard. What it basically means is that if you say that S is a subtype of T, it means anywhere where something expects something of type T, I can use a value of type S without breaking behavior. This is what it means for something to be a subtype of something else. Liskov substitution principle is a special type of substitution relationship, which is called strong behavioral substitution, which was defined by Barbara Liskov and Janetta Wing in 1994. And the succinct formulation is let phi of x be a property provable about objects x of type T, then phi of y should be true for all objects y of type S, where S is a subtype of T. This is basically a whole idea where, like, okay, if I have something of type T, then if I use S instead, then it must have all of the properties that are guaranteed by T be also respected in S, which, click it again. Now, in less math terms, what it basically means is that preconditions cannot be strengthened, postconditions cannot be weakened, invariance need to be guaranteed and must be preserved, and then we have this thing which is called the history rule, which is constraints must be preserved in the subtype. And the history rule is the part where a type checker cannot help you. Constraints are not able to be defined in the type system. If one of the constraints is that I output something to this file, the type checker can't check that, yes, your subtype outputs to this file as well, or to a file. And this is something that, as like developers, you need to take care of. Like most of the other stuff, invariants, preconditions, postconditions, the type system and PHP will happily shout out to you if you break them. History rules, it can't handle this because side effects are a thing, and the main point we use programming languages is because we want side effects, and so that they impact the world around us and do something. Basically, in other terms, and again, visualize is, if you think about data and like how you combine functions and method calls and everything, for something to be a subtype, you need to be able to replace it in place of something else. So yeah, you can widen the precondition, so I can accept more stuff, so I can use it in other places, but by replacing it in this pipeline, well, it still works. And I also can make it stricter for what it returns, because any code which is expecting, let's say, an integer, a string, or an array, if I only start returning an integer or a string now, well, then it already handles the array case, which is useless now, but it helped, like, yeah, I suppose it's more, this is the whole principle and point that we care about, and like what makes a subtype. The clicker, please, stop working. So the effect on LSP on signatures and what you will do is that methods cannot take mandatory, like you can't add mandatory parameters in a subclass. Parameter types must be contravariant, i.e. you can widen them, which will more explicitly a supertype, and the return type must be covariant, so a subtype, and property types must be invariant, so you can't change them, you can't make them covariant nor contravariant. Or they must be, no, they must be co and contravariant because they are invariant. So in general, the really easy and simple rule as to what makes something a subtype is, well, if T is a type list of, I don't know how many elements, if it's a union type, then I can remove something from the union type, and it will be a subtype. And if I'm just adding an intersection to my to my subtype, or it's the same type, and I just add some intersection, then it becomes more restrictive, because, I mean, I suppose we could go back to the initial case, to the initial thing where you had like C, and T. The thing which covers C and T is like really small, so it's a subtype of the whole sphere. Please, the clicker. So yeah, like a couple of PHP examples to demonstrate what are actual subtypes. So okay, got level union types, remove a bunch, I've got a subtype. Got a bunch of intersections, I add more intersections, I've got a subtype. And then we get into the really odd, like the tricky cases, is if I have something which accepts something of type A, it doesn't mean that it can't accept the union as a subtype, because X and Y both implement A. And X and Y are two types within the world where A lives. And so these two things are a subtype, and me just combining these two types makes it like a larger blob than each individually, but it's still contained within A. And it's the same thing with intersections. So if I have A and B, the fact that X and Y both implement these both interfaces is you get into the same thing. It's like A lives here, B lives here, but X and Y live in the intersection of both. Therefore, me restricting it to a union of these two types still makes it a subtype of the intersection of both interfaces. The clicker. One example was DNF types, which is basically just, okay, I have an intersection which X and Y satisfy, or I have D, which is its own type on its own. And the reverse is kind of also true. It's like I can have a union of A or B, but X and C is a subtype of it because, well, X extends A, so it covers the whole, like the A part of the union, but I'm just adding a restriction of the types of X that I'm returning. Yes, so the whole rules about how something is a subtype of another get split into two, if the subtype if the type I'm trying to check is a subtype is a union type, or if it's an intersection type. So let's start with the easy case, which is U is a union type. So a list of types U1 to UN is a subtype, like, so U1 to UN is a subtype of the union type V1 to VM, if, and like only if, at least for all of the UIs, there exists at least one type in V that satisfies the subtyping relationship. Again, if like U is now for U to UN is a union type, but we're trying to check if it's a subtype of an intersection type, then we need for every single UI, we need it to be a subtype of every single type in V. So for every V, so V1 up to VM, I need U1 to be a subtype of V1 and V2 and V3 all the way up to VM, and the same for U2 and the same up to UN, to make this union type a subtype of the intersection. And to do this, we iterate over the types of U because we can just check, okay, well, I go through U and I check. So maybe some PHP code explains this a bit better than just some obtuse math language that you probably haven't seen in, I don't know, since university, if you even did any math. So this is the basic idea how it checks for it. It's like, okay, we iterate through all of the types in U, we check if it's an intersection type, then we need to check that, okay, this is an intersection type of V, otherwise, well, is it a single? And the moment we get that something is not a subtype, then we can just bail out. And like I said, the more complicated case is if U is an intersection, and we're trying to check if U is a subtype of V. So the formulas just look very, very, like the formulas look identical for the most part. Like, I mean, I'm pretty sure, like, yeah, if I go back and you stare at like the equation 1 and 2, and I go here, it's like, what changes? So what changes is basically the order of how I am conditioning on the list of types of V and the list of types of U's. And because we are changing the order, this changes fundamentally how we need to operate on checking the types. So for an intersection of U1 up to UN to be a subtype of a union type of V1 up to Vn, we just need a single V type, like a single Vj, and a single UI to be subtypes of each other. We need only one case out of all like the possible combinations. We need one. For the other one, we need that every single VI has at least one UI which is a subtype, which is basically the rule that, like, okay, I have a list of intersections and I can just add more intersections to it. That's basically what it means. But the fact that the order of the for all and the exist things are called quantifiers, and the fact that we change the order means that we need to operate in a completely different way, which is as follows. we basically need to iterate on the types of v instead of the types of u first, which took me 3 months to figure out, but we've got there. It took a while. So yeah, that's basically what I've did. Simplified in PHP code. I mean, I don't know if I should read it or if I should let you stare at it. I'm seeing faces being like, what the hell is he talking about? What is this thing? Do I ever need this? No, you don't. That's my job. That's my job to take care of. But yeah. So now that we've talked about what PHP can do and how it does it, now what might be in the future of PHP's type system? Who knows? Maybe one addition could be function types, so that you can type a function that you want to pass. For example, that the function I want to be callable takes an integer as its first parameter and a string as its second one and returns a Boolean. That can be useful, like any sorting. I mean, array sort like expects that you take it like an import and then it returns like -1, 1, or like 0 or 1 to be able to do the sort. Generic types, if you do anything with typing, you would very much like generics, I suppose. Like the main use cases is for collections, to be able to not need to re-implement 20 times collections, like, oh, I want the collections of cats, and I want the collections of dogs, and I want the collections of whatever. It's just like, okay, let me give a collection of a type T, and I can only add this to this like collection. Again, the clicker. User-defined type aliases, so that would be also convenient uses. Like, for example, I mean, these are 2 imaginary syntax I just came up with. It's like type def numeric in float, or type numeric as like a union type. The main point, I think, for type def gets really complicated when you have like a lot of intersection types, or you're having like DNF types and stuff like that. It just becomes a pain to write them every single time, and it would be a very useful feature, but as always, implementing stuff gets very harder. In-out parameters are an improvement on the type system and an improvement on references, because references currently in PHP are really bad, in the sense that if we replace the in-out with like an ampersand, I can pass an array as a value, and yeah, I can change the v to 5, and then after the call to the function, a would be 5. Like, okay, you give me an array, and you're just converting this array to an integer. It's like, why on earth are you doing this? But in-out parameters fixes this because it guarantees that, oh, okay, the type that you pass in must also be the type that you pass out of the function. So yeah. So this is the fun part for me, because this is my therapy session, because I will now inflict upon you the pain of all of the ways PHP does type juggling in magnificent ways and unbearable ways. So, small question. I just want you to raise your hand. Like, nothing important. It's like, who has heard about strict types? Lot of hands. Who knows what strict types does? Okay, way less hands, way less hands. Okay. So, PHP has 10 type juggling contexts, which all behave slightly differently. The first one and the easiest one is the string type juggling context. So this is a context when you use, you're trying to print something, or you do string concatenation or string interpolation. So it will basically convert the value to a string. So yeah, you can concatenate true, and you get 1 and hello. You can concatenate an array, and PHP is like, yeah, sure, yeah, here, array, because it's an array, so here's just the word array. Now, it will type error if you try to concatenate or print an object which is not castable to a string, but that's the only case where it type errors. So you got, the second one is integral and string types, which is the context which is used when you use bitwise operators. So if both operands are strings, then it does the bitwise, or the thing like byte by byte. It does the bitwise operation byte by byte. Otherwise, if you have a number and numeric strings, it converts it to like an integer, and it now does like integer like stuff and computes it, but then it will accept this for anything. So it will basically convert any value to a number, except if you're dealing with an object which implements operator overloading. So internal objects, so objects which are defined by its extension, can overload their operations. So this is what like the GMP object does, which is for like multiple, like arbitrary precision, which will then use its own bitwise function to bitwise 36 with the arbitrary precision 25. Now the other thing which I've discovered, so PHP objects, like internal PHP objects, can also decide how they cast to other types. And for some unbeknown reason, the tidy extension, which is about sanitizing or cleaning up HTML, decides to implement an integer cast. So yeah, you can just pass it a hello world like HTML, and it just says like, yeah, this is equal to 0. So you do a bitwise operation, it says, yeah, here's 36. Like, I don't care, I don't even complain, do whatever. Now, if you try to pass a non-numeric string with an integer, then you get type errors, and finally a bit of sanity, and like just type errors. But yeah, some other weird stuff. So the numeric type juggling like context is similar to the integral one, but it converts values to float or integers. So if you try to do addition with two numeric strings, it will convert it to float. So PHP has this concept of scientific notation. So 1e3 is equal to 100. No, is equal to 1,000. I don't know how powers work. I just did a maths degree, you know, but it's fine. It does it. It will convert true to like 1, 0 to 0. Same with GMP. It overloads the addition, and it does that. Again, this weird tidy object just converts it to 0, and it's just like, yeah, sure, add me, like whatever. So now logical types is like if you do like a conditional, like if I do if something, or use a ternary operator, or like you're doing like a logical AND. Now surely, converting to Boolean, nothing can go wrong. Like, okay, brilliant. So again, because internal objects can overload the cast, but then they can also say that they do not support casting to a certain type, which the GMP object does by not allowing a cast to Boolean, and so you get this recoverable fatal error, which it's the only place in the whole code base where this error gets emitted. Like it was previous to PHP 7 when like the engine didn't throw exceptions and errors, it threw these kinds of things. And I tried fixing this, but the problem is like, throughout the code base, it just expects like Boolean casts to work. So fixing this is really hard, and this just bails out the engine. It's just like, stop whatever you're doing, we're just exiting, which I might try to spend some time again, but it's really difficult. So this is my expression when I saw this the first time. I was just like, great. So comparisons. So this is just a context. Okay, when you use like any comparison operators, yeah, PHP has 2 different operators. I don't know if you knew about that. The second one is technically how you're meant to do different in SQL, but nobody does that. So this is the table on the PHP documentation. If you go to comparison operators and it tells you what the order is, it will first check if both types are like one is like a strings or like string and null, and it will convert null to an empty string, and then it will do a numerical or lexical comparison. The fact that it does a numerical one is very strange at times, we'll see. Okay, so if you have a bool or a null and whatever, on the other side, it's like, okay, it converts both sides to booleans, which we know can fail. And then we'll like, okay, false is less than true, which, I mean, yes, because false is 0 and true is 1, but having an order on booleans is a bit weird. Okay, objects, okay, so built-in classes can define their own comparisons. As always, the internal objects can do whatever they want. You might have been using this with datetime, right? You can compare datetime objects. But But yeah, otherwise, same classes can compare, like we'll compare the properties and say it's like, oh, these two properties are equal to each other. And otherwise, if classes of different, if objects are of different classes, then they're considered like incomparable. If you have a string of resource or a numeric, well, something which can be considered as a number, it will translate the string and resource to number and then usual math. This table is a lie, because in PHP 8.0, we changed this behavior. So if the string is not numeric, it will cast the integer to a string. But yeah, we need to update the docs. Okay, arrays, comparing two arrays, it's like, well, array with fewer members is smaller. Okay, that makes sense. And if the key from the first operand does not exist in the second one, then the operands, like the two arrays, are considered incomparable. So the order in which you try to compare arrays is important and matters. In all other cases, normally object is always greater than whatever else, and array is always greater than whatever else, which clearly has some implications. So an empty array, when you compare with true, well, like it casts the empty string, the empty array to false, and therefore the array is less than true. Numerical strings compare as integers, so 1 is equal to 0, 1, yes. Then you have the ones with scientific notation, so you have, okay, but because 0 to whatever power is still 0, so these also compare equal, which is great. How PHP encodes that two things are incomparable is by basically always saying that like op1 is greater than op2. So yeah, like we just flip the order of the arrays and we get the same answer. Because sure, why not? Same thing with objects. Like this is the same behavior with objects. So you can see you're comparing like the standard class with like this tidy object, and yeah, they always get the same thing, right? Okay, so this is what the table tells us, and this is what we should be expecting, right? At least the docs aren't lying here. But then we were told that, like, normally, like, why am I getting a type error now here? Like, I've just inverted them, right? Like, so GMP like overloads its comparison thing to be able to compare with integers and do its own thing. But if you're trying to compare it to something which doesn't know, it's just like, oh, here's a type error. But only if you use it first. Because otherwise, it uses the comparison handler of like the standard class, and then it's just, okay, whatever, it's fine, like I can't deal with this. Which, brilliant, that's brilliant, consistent behavior. But then, I thought objects were also always meant to be greater than anything else. Why does it try to cast this object to an integer? And now 3 is greater than an object? Because honestly, I haven't figured out this behavior. I think it just tries to cast. It then it casts to a Boolean, and then because it's like, I don't know. But yeah, again, the tidy thing, because it just defines a numerical thing, it will just cast it to an integer and compare 3 to 0, which, sure. Yeah, I mean, don't know how much I'm boring you, but it's great for me. Like, it's tremendous amount of breathing air. Like, same thing, I mean, okay, so the 5.5 was like the GMP is like, so GMP overloads the comparison operator, so that makes sense. But then if you try to use a floating string, it complains that the number is not an integer string, and you get a value error, which is also consistent and brilliant. So yeah. So functions, this is what I think most people use all the time. It's like, okay, you call a function, you return something from a function, everything. So in this context, the value must be of the type declared by the type declaration of the parameter, or the return type, or the property type. Except in these 3 cases. So int gets promoted to float automatically. If the types and the values are scalars, then the value gets converted to the appropriate type if compatible. And otherwise, if the string types accepts objects which are castable to strings. Small note, internal functions prior to PHP, well, still accept null or coerce null to the scalar types. This is deprecated as to PHP 8.1. So Into floating is, yeah, I'll pass a float, I pass it 15, it dumps 15. Sure, most of the time that's not an issue. So the coercion for scalar types, if you have multiple scalar types, it will try to coerce it first to an integer. If it can't do that, then it will coerce it to a float. If it can't do that, it will coerce it to a string. And if it can't do that, it will coerce it to a Boolean, which has this weird implication with floats, because we've deprecated casting floats to integers which lose precision. So, like in PHP 8 and like PHP 7 and PHP 5, you'll get like the 15.6 gets truncated to 15. In PHP 9, when this becomes a type error, you will get a string, which might be a bit of a caveat and to pay attention to. Again, okay. So, again, small tweak of the rules. So if you're trying to pass a string to a type which accepts ints or floats, it will use the numeric string semantics. So if you're trying to pass something which looks like a floating point number, it will convert it to a floating point. If you try to pass something which looks like an integer, it will pass it as an integer. So this is actually sensible, and for once PHP gets something right, which is great. So string castable objects, so that's the third case, which is, well, okay, so you define a toString method, and you pass it to this type v, and it will just use it. Now, I'm not using stringables, all objects which implement toString. I'm very careful with my words. I said string castable, because GMP, again, lovely GMP. If you ever need a weird object to test in your code base, just instantiate one of these objects and just throw it around. It is brilliant. It does not implement the stringable interface. It does not implement the toString method, like magic method, but it still casts you a string, which is brilliant, which is great. That's something we probably need to fix in PHP core, to just make it, like, accept this. But there is no guarantee from the engine that, like, okay, every value that can accept a string type check implements the stringable interface always a string, which is incredible. Okay, this is my topic at the moment. So increment and decrement operators. So you can increment in like integers and floating point numbers, and like it does +1 and or -1. Really sensible, great behavior. PHP has this feature where it increments strings, which it picked from Perl, which it's fine. But then okay, so time juggling. So okay, so you can't increment an array because that doesn't really make sense. Like, you can't increment a resource. Like, okay, like incrementing resource, what does it do? Like, that's kind of pointless. But then it doesn't cast booleans to numbers, and it just like does nothing. Like, it doesn't even warn. Like, it's just like, yeah, sure, whatever. Like, here, that's fine. You know, fair. Now, it will, okay, so if your strings are numeric strings, it will convert the string to an integer, and then it will cast it as an integer, and then it will add, like, okay, which is sensible, you know. At least this makes sense compared to the string increment. But then, okay, so we can also increment and decrement objects, which works very fine for the GMP object, clearly, but not with the tidy one. Although, we could add it earlier. Like, I don't know if you remember, we could add stuff to it. But you can't increment it, because that's consistent. So, okay, like I've been talking about increments and stuff, or like decrement. Okay, but like, null should be somewhat sensible. But okay, if you try to decrement null, it does nothing. It just get null. Okay, sure. And when you increment it, you get 1, because clearly having an asymmetry is amazing in a language, and great. And if you try to decrement like a string, like you get nothing except if it's the empty string, because then it casts the empty string to 0 and you give -1. So when you increment this, well, like I said, like the string increment, you get like FOB because it increments to O to the P and like that. But if you increment the empty string, you get the string with the letter 1 in, like with the character 1 in. You don't get an integer, you get a string, which, amazing, it's amazing, right? It's amazing. But the string increment only works on ASCII strings. So if I'm trying to increment like a non-ASCII string, it does nothing and also doesn't warn. But it's also very bugged in how it does the string increment. Like, okay, it does if I have just Z, it increments it to AA because, okay, like it overflows, so Z becomes A, and then you add a carry and it does A. But if you have a trailing white space, then it's just like, wow, nothing to see here, I don't do anything. And if you have a leading white space, it converts the Z to an A, but then it just loses the carry. Because why would you need it? It's just like brilliant. Just have like, if you want to do mod 26 instead of using integers, you know, the smart way, just do that. You know, just do that. So okay, well, we've been talking about like incrementing strings, you know. But okay, like I have this string, I just incremented 100 times. You know, obviously I'm going to get a string, which clearly we're getting a floating point number, which is me. So the reason why this happens is while doing the iteration, we get to 5D9, which gets incremented to 5E0, which now is a string in scientific notation, which gets cast to a float, and then we continue adding stuff there, which is brilliant, it's great. Okay, we've been talking about stuff. Arrays, we all love arrays. Our God structure. So a normal key, like a string key, we've got this integer key, we've got like 007, and we've got an empty key, right? Okay. Like, so 5 becomes 5, the string key stays. If your key is a pure integer, then it will cast it to an integer. But only if it's not a numeric integer, it's like it needs to be just an integer. Because you keep the 007, and having an empty string as a key, I don't know if you ever needed that, but that's a useful feature. So how does it do with type juggling, right? Like, normally when it accepts string and integers, like all of the other types get converted to integers, except here, because no gets converted to an empty string, but the rest gets converted to integers, so okay, sure. Floating point number, well, I say floating, I have float and I have like a string as a floating point number. You'll get a warning, you're getting something that's deprecated because the 15.5 gets truncated to 15 because it gets cast as an integer, but the string is just like, here's just your string key. Like, I don't care. This is fine. If you try to use a resource, it casts the resource to an integer, because sure, why not? Now, then we get into the sanity stuff. It's like, okay, you try to use an array as an array offset, you get a type error. If you try to use an object, you get a type error. Even if it's stringable, you still get a type error. So at least this is consistent. And it's the same if you're trying to unset these keys. It's like it will do the same conversions and it will do this thing. So like, at least it's logical, like it's consistent, you know. It's like, okay, like I'm trying to unset stuff, okay, I get type errors, or it does the conversion. And same if I'm trying to do like empty or like isset, it's like, okay, you get the things, and it's just consistent. It's like, okay, the behavior might be weird, but it's consistent. I'm sliding through because I'm just seeing how much time I've been spending with you. So string offsets, like, okay, like, probably you've already used it to do, I have like the alphabet here. I can access the letter 6, which is G, which is my initial. Now, surprisingly, I found it surprising, PHP seems to actually care that you only use integers if you try to access a string offset. It's like, it will warn that, okay, you're doing a cast has occurred, and like it will tell you, which is great. It also does it for floating point numbers, then not for integer strings, because then it takes the integer string and casts it to a number, and then it's fine. But then if you try to use 19.0 as a string float, then it gives you a type error. Because obviously accessing an offset with a string doesn't make any sense, because it needs to be a number, which does make sense, right? Okay. And same thing, so okay, you can't use an array, you can't use a resource, and you can't use objects. So you get type errors, great, amazing. Now, you can't unset a string offset, that's kind of weird. Like, you're having a string and you're unsetting an element in a string, like, doesn't really make sense. So it tells you that you can't do it, but the error depends on how you are accessing this element, which is a bit fun, but sure. And clearly, like, it's consistent like arrays, it also doesn't warn. So yeah, now PHP does the type juggling and conversion completely fine. It will tell you, it's like, yeah, sure, you can, like, the element doesn't exist, or it's not empty. Sorry, I've reordered the slides. So it's not empty, like the element exists. It will now tell you that you're converting from a floating point to an integer, instead of just warning blindly. And it will do the same thing, and it will also accept keys which type error. So, but it will tell you that, like, these things don't have any value, which is at least good. And obviously empty and isset, like, are implemented the same way, so the behavior is equivalent. And isset is behaves the same way as, like, the null coalescent operator. So yeah, you get the same. You get the letters because it converts it. Then you get, like, default because, okay, like, it can't convert the 19.0 to a string, and then it's fine. But you get type errors if you use resources and arrays and objects, which you don't if you use isset, because being consistent is PHP's nightmare. Truly my reaction. Okay, so we're getting towards the end. So exit accepts either an integer or a string. So if you pass it an integer, it will exit the process with this code. And if you pass it a string, it will just print out this to like the console or whatever. Now, if the value is not an integer, then exit will just convert it to a string. So if you try to pass null, it will just print the empty string. If you pass false, it will print the empty string. If you pass true, it will print the string 1. Took me quite a while to figure this out because I was using a CLI script once. I was just coding it. I was just like, oh yeah, I have a Boolean state. Are there errors or not? And I just passed build to the exit, expecting it to convert it to an integer, and it does not. Which same thing with 15.0, which is a float. It converts it to a string and just prints this. Which implies that, okay, it also will cast the array to a string and then a resource to a string and tell you that. But objects cannot be casted to a string, so then it emits a type error. So I cannot, like, if you pass an object to exit, you can just catch it and do something else if you want. So yeah. So yeah, we've covered a lot. Like, I'm proud of you. So out of all of these type juggling contexts, like the 10 we've seen, strict types only affects the function one. Like, out of all of these things, we got, like, this tiny thing, and even then, there are caveats. So strict types is only enabled in PHP scripts which define the declare strict types at the beginning. It disables coercions of scalar types in these cases only. If you pass an argument to a call made in userland, if you return a value from a user-defined function, or if you assign a value to a type property. It does not change the behavior of, well, the binary operations, nor comparison operations. So you still have, like, the weird ass, like, okay, 1 is equal to 0, 1 stuff, or like if you use octal numbers. It also doesn't affect exit. Like, okay, I still pass true. I still get, like, it prints at 1. But I think the more important one is that not change the behaviors of functions which are called by the engine. So if you use array filter, which will call your callback, even if you define your callback in strict type mode, PHP will use the coercive typing mode to type juggle the values. So you would probably expect, if I pass array filter in strict types, like if you would do a re-implementation in userland of this, you would only get the values 3 and 4. Well, you would get type errors, but it would only keep 3 and 4 if you would ignore type errors. But because the engine doesn't care, your array ends up with strings, with integers, and, like, strings which look like floating point numbers. And I think this is the most surprising and maybe dangerous in some sense that you won't expect, which kind of gets to my hot take that strict types was a mistake. Because fundamentally, you need to know about how PHP type juggles. Because if you call an engine function this is what will happen. If you call a comparison operator, it will type juggle. If you use array offsets, it will type juggle. PHP will type juggle even if you use strict types. Strict types is such a narrow definition that it doesn't cover all of the breadth of what happens. So yeah, that was my talk. Thanks for coming.
Thank you, George. This was far over my head, but you guys, you probably, yeah, you're good. Any questions to George? Come on.
I don't bite, I promise. I don't bite. Okay, we've got one.
Yeah, that sounds good.
Thank you. How much effort would it be to have like a declare strict all and get rid of all these coercions?
So, I mean, so like I say, I care about semantics. So one of the IRCs I'm trying to push is to like change the semantics of the increment and the decrement operator to be basically the same as doing +1 and -1. So, which still means type juggling. The thing is, we don't usually like, the thing is declares just aren't great, because if I write a library, I mean, sure, like in your library you do, but like, you still need to support basically two, like the engine needs to support two cases. And my opinion is that it's better to make the engine, frankly, less stupid, and like be more sensible with what it coerces and how, like, which might be weird. Like, I quite like the fact that I can type juggle numeric strings and pass them to integers, like to a function which accepts an integer. Because if I just pass a string file, it will, like, I can just use it, okay, like it has a CSV file, and I get a bunch of strings which are integers, and I can just pass it to like addition or something like that, and it will do stuff. I mean, we could have a declare, but you're fundamentally changing a lot of semantics of the language, and like comparisons, like the problem with comparisons is PHP does not have an internal representation of what uncomparable means. Like uncomparable for PHP is like, oh, just always return greater than. Like it's, so I don't think it's a correct fix. It's my perspective on this, at least. So yeah. Thanks. Don't know if we still have time, or I've just been talking too much.
Anyone else? Yo.
I wanted to ask if there are any more of these fun differences between prefix and postfix increment and decrement.
No, these I mean, I suppose just go on to like the PHP wiki for the IFC and just read the IFC I've wrote. You will get literally every single behavior. Like, and I've done a comparison with Raku, which is the successor of Perl, from where we got this implementation. Yeah, PHP, this is mainly what it does. It's just it will only properly cast stuff if you get like a proper like ASCII string. But that's what it does. Otherwise, it just doesn't do anything. So, yeah.
Thanks.
All right, so we have to change the rooms and give another round of applause for George. That was great. Absolutely nice. Thank you.